All right. Hey, everybody. Welcome to Cassandra Lunch 32. We actually have been discussing earlier some discrepancies in a backup restoration scenario using SS Table Loader, where Dipan, who's on here, was describing a scenario where consistently, going from a 9-node cluster to a 3-node cluster, backing up the SS tables and using SS table loaders, there was a 15% discrepancy. He also mentioned that DS bulk, using DS bulk to get data out and get data in, it was always consistent and the data matched. But it seemed like there were two potential scenarios that could resolve it, or remedies that could resolve it. One would be to run repairs and then to do a major compaction. So we'll stay tuned, Dipan, if that will work. Maybe we can have an actual presentation about why the root cause was, like how do we make sure data gets restored properly. So what I did today, based on that discussion earlier, was to come up with today's topic, which is just Cassandra Data Operations. Just common ways to move data in Cassandra, and that's what we'll talk about today. Akwi, thanks for again organizing and recording and putting the content up after we're done. Always looking for people to come and help us, to get sponsors or speakers. If you want to speak, please put your name in the chat and we'll queue you up. Actually, one of the things that I'm going to do differently in 2021, this was an ad hoc meetup that we started, and we started seriously doing it, and now we've done it 32 times, is that there's a general outline of topics on Awesome Cassandra. And Awesome Cassandra is, it's a README that I've curated over the last, I don't know, 2-3 years. And then this was the beginning of the Cassandra.link website. Every now and then we collect a lot of curate content to Cassandra.link, and we take the best ones and we put them in this document. And basically, if you read through every article, I didn't put all the videos there, but there are some key videos. I think I'm going to go back and add more videos to this. But if you go through every single one of these articles, you will be an expert at Cassandra. And I'm going to put a little bit more TLC into it to update it based on new content that we've added to Cassandra Link. But it got a pretty good table of contents, essentially. It talks about use cases, different distributions of Cassandra, using Cassandra, migrating from relational all the way to deploying. So we've talked about a lot of this stuff, but there is a table of contents here that we can follow, and we'll try to find the author to come and speak about it if they're still in the Cassandra world, or we'll just talk about that topic, and we'll go look at the article and see what the value is in that article. But it's not going to be like, we're going to read every article. What we're going to do is we're going to take the gist of these articles. We'll publish a blog post about it. We'll have potentially videos about it. And that way we'll cover everything in Cassandra that one may need to know. And, and additionally, if there are, ad hoc speakers that want to talk about something, we can always make room for it. But that way, we'll have a structure for the whole year. At least 52 topics we will have planned out for every week of the year. Maybe we'll take 2 weeks off for vacation. So anyways, looking forward to 2020. We're almost there. Data Community DC, we're part of Data Community DC, which is a large community of diverse folks from different backgrounds. We're always looking for speakers from different underrepresented minorities and communities to speak. We're part of all these different meetup groups. Another thing that you should be aware of is that we run a meetup group called Data Wranglers DC, and Data Wranglers DC has a weekly Monday lunch and learn meetup, same time frame, where we cover data engineering, the whole discipline of data engineering. And yeah, we cover some Cassandra, we cover some Spark, but really it's the holistic data engineering, data operations aspect of what we do. What we cover here is all things Cassandra, Cassandra protocol, different types of Cassandra, how to get data in it, how to get data out. In fact, that's what we're going to talk about today, data in, data out of Cassandra. Normally at this time, we'd ask somebody who's new to introduce themselves. I think we have mostly folks who have been here before. Group rules, if you have a question, just ask it in the chat channel, or you can ask it just ask it, just unmute yourself and ask. Be polite. This is a community. That means it's a conversation. It's not a one-way thing. The only reason I come up here and present is that I want to make sure that this thing continues to go forward and that we have this knowledge out there. And so if there are other people that want to help put the knowledge out there, either by leading in terms of doing a presentation, but really what you're doing is you're leading a conversation. All I do here is lead a conversation, and everybody else is welcome to be a part of it. Our company, Anant, we focus on Cassandra-based platforms and basically the things that go around Cassandra, Spark, and Kafka, and the DevOps and the data ops around it. DataStax is a partner and a sponsor of this group. So is George Washington University. I hope they start opening up so we can have these meetups in person. And when we do have these meetups in person, we will continue doing the lunch and learns, because I think it's very valuable for folks that can't get out of the office. Here's some local sponsors, in Chicago, Waveful in Chicago, Eastern Foundry in DC. And of course, our organizational sponsors. These folks allow us to fund the meetups, even when the individual meetup, it can't support the pizza and soda costs. And then they also help us put together Data Week DC. This year it was all virtual, but they were very instrumental in getting the word out, paying for press releases and things like that. And we are a nonprofit. Data Community DC is a nonprofit. So all of these quote sponsorship money that came from their advertising budgets and marketing budgets were basically tax deductible. All right, any announcements from the team or the gallery here?
Hey, Rahul, not much of an announcement, but just a thought. I could, if it is cool with us, I could definitely talk with teams at Capital One to see if they would like to hear our perspective from here, like how we do data wrangling. If they are interested in, let's say, exploring certain methodology to ingest, process, or sync data, maybe we can accommodate. What do you think about it? Or what does the community here think about that?
I think that's great. Actually, Capital One had sent some people to the Cassandra meetup a while ago. So I should reach back out. Yeah, it would be great to have people actually also present from Capital One. I know they're one of the banks. There are a few different banks that I know that use Cassandra. I know for sure Capital One uses it.
They do, yeah. They have a separate channel and everything on Slack just for that. But not my org. None of us use Cassandra yet. Gotcha. But I was thinking more like from the perspective of next gen, ETL or where the trend is moving. Well, one of the things that I see that analytical and transactional are widely different. So there has been trained, and not just at Capital One, any other place as well. Like they would move stuff from transactional to the analytical, like to Redshift or to Snowflake, from RDBMS, from RDS. But there could be like one solution like Cassandra or even thought about that, like the seeding process, right?
Right.
Of the thought. So maybe I could talk there something if that's cool with us. And then, in future, I don't know when we could do a meetup there, virtual or physical.
Oh yeah, no, and I'm the one at fault. They had actually told us we can come out to Tyson's, and I'm just lazy. I don't want to go to. But I think nowadays, since everybody is remote, no, that's a great suggestion.
Okay.
Yeah, why don't you reach out to them, and then I'll also reach out to some folks. I know that they have a lot of folks that can talk about Cassandra, and we can definitely share a lot of knowledge. So good idea. Definitely. Let's follow up on that.
Cool.
Akwi, if you want to put that in our backlog, you know, kind of reach out to Capital One. I know that they would be interested, because the guy even said, he was like, we love that you guys are doing this, and then we had a couple of meetups, and then the COVID happened.
Cool.
Yeah. All right, let's continue. So we have a couple of you know, events coming up. So tomorrow, not tomorrow, so yeah, tomorrow there is an event related to just general Spark and using distributed machine learning frameworks. It's not related to Cassandra, it's related to Spark, but a lot of people that use Cassandra use Spark. And then over the next couple of weeks, presentations on you know, Spark as a service, so Databricks, and Cassandra as a service, which is Astra, and how to connect those two and how to get it to work. I'm actually really interested in seeing this because I've been doing some Databricks and Data Stacks work, Data Stacks Enterprise, and I have not touched Databricks with Data Stacks Astra. I'm really curious to see what it takes to get that working. We have these videos recorded for perpetuity. Maybe next year we'll start doing this meetup simultaneously on YouTube. We've been doing that. We've been experimenting with some of the other webinars using YouTube Live. But the thing about YouTube Live is that it doesn't really support a two-way conversation. It's a one-way thing. But if I can figure out how to do Zoom and YouTube Live, I think we can do it. Otherwise, there's a way to do it with Skype. Anyways, and of course, we have Cassandra Link continues to be worked on in the back. We're doing some interesting things for 2020 where we're going to use some paid APIs to enhance the data, extract companies from the jobs, extract topics from the content, not just our human curated tags, but NLP extracted tags. So looking forward to 2020. And with that, let's get right into the data operations. So you know, I didn't put the outline here. It's actually in the document. But as I go through, I will you know, put stuff in there because this will be the backbone of the blog post. So there are various different ways to move data, in my experience and our experience here at Anant, for moving data in the world of Cassandra. And what I mean by there's various ways of doing it. I'm saying that there's no right way of doing it. It just really comes down to you know, the criticality and what needs to be done. So today, what I'm going to cover is an overview of all of these. I don't think I can do a demonstration of all of those. I think that would be actually very useful. Like how to move data with, you know, what we were talking about earlier with Dipan, you know, SS table loader, how to move data with Spark, either using scripts or a compile job, or for example, a third-party tool. And there are, and I actually have to update this, there's a couple of schema migration tools that are out there as well that are really nice that we have not added to it. So there's two types of data migration. There's online and there's offline. So, you know, and when we say offline, offline means that it's, you know, you do a backup, right? That's one way, and then you do a restoration. That's one. Another way would be that you have, you know, disk snapshots. You bring up a new cluster and you attach the disks, right? That's also a way to move information. And, you know, these are good for disaster recovery. These are good for, you know, cloning a cluster, but generally speaking, that's what they're for. Then there are online operations. And so online operations are a little bit more nuanced based on, you know, what is the goal. And, you know, either of these scenarios, there's a little bit of an overlap in which you can do the same operation offline as you can do it online. And we'll talk a little bit about why would you want to have that freedom to do one thing online and offline. But generally, operations online involve potentially changes to topology. That's one. In the Cassandra world, I mean, that would be the first way to move information, is to bring up a data center, synchronize the data center, and then disconnect the data center. But that takes a lot of effort. And honestly, like, if you're not going to use Cassandra's topology to move and synchronize data in your daily online operations, then you want to do other types of, kind of keeping things in sync or moving data, that's fine. But generally, the next thing is, so Cassandra changes to topology in Cassandra. That's one way to do it online. The other way is to do it using essentially queues and streams. And you basically mirror data, right, to different places. And this is not exactly event source, but it's kind of like event, sourcing the data / CQRS. Then there are tools, and mostly, and I was just saying Spark, right? If you want to do online movement of data, Spark is kind of the end all be all. It gives you a lot of abilities, but there's ways to do it with like a script or like a compile job, and then we'll look at something called the Migrator. And then finally, there's just CLI tools. DS Bulk is one of them, and Dipan mentioned this earlier. You can also use copy in CQL SH. And what I mean by these are, you can use this online. I mean, you don't have to bring down a cluster, or you don't have to you can have 2 live clusters to do this. But the thing is that you can also do this offline, meaning you can take the data out, right, move the data, and then bring it back in another one. You don't have to have two live clusters, but you at least need one to be online to do this. And with the Spark, same thing. If you're taking data out of a cluster, saving it to disk, and then going to another cluster, you at least need one live system. And maybe I will just put here, SS table loader as well. But this is the high level overview, right? There's some offline operations and there's online operations. This idea of moving data, migrating data, it's not just for backup restoration. And so data operations around Cassandra data, it's about thinking about it as every time that you're doing this, it's a migration of data. But people need to migrate data sometimes in the same cluster, meaning they do a schema change, right? And you change the partitioner, you change the partition key. So you have to basically you have to move the data from one table to another. How do you do that? So data migration is not just for moving data from one cluster to another. It could be from moving from one key space to another key space. Or it could be from moving from one table to another table in the same cluster. Generally speaking, a migration of data requires you to do something with schema, right? You export the schema, you make changes to the schema, and you import the schema. And then you move the data, either using online or offline migration methods. And then finally, you do some sort of parity check to compare that this happened to this work. This same thing, if you didn't have to do any schema changes, you would still export the schema, make 0 changes, import the new schema, and then you go about the same thing, right? And then online migration, there's kind of 2 ways to do this. One is either dual writes, meaning you write to both systems, or you do it through a persistent queue. So that means your software basically is saving data to at some point after the schema migration, you move the data and you continue writing to data. You read from B, but you write to A, and you write to B, and you validate that. And after a while, you validate it. You stop dealing with B altogether, and you essentially, you write to A and you read from A. And any time that you need to do a mass update, you can redo this without having to do a schema migration. But that's just called the dual write method. The other way of doing it, and this kind of the document kind of walks through the different steps. The other way to do it is through doing it via persistent queue. In this particular example, we're talking about RabbitMQ, but it doesn't need RabbitMQ. You can use any persistent queue. In fact, something like Kafka, you don't even need a replay queue. All you really need is the offset to replay after. In the same topic, you just say, start from the beginning. And so here, what we're looking at here is one cluster. One aspect of the data center is for processing, and the other aspect of one aspect of the cluster is for processing data. Another aspect is for serving data. And then we have two sets of those. So one is A, one is B, meaning, like blue and green, we have A and B. And in this case, the processor is Spark. It doesn't have to be Spark. It could be Kafka Streams. It could be Akka. It doesn't really matter. It could be Python for loop, right? All the writes are happening after processing the queue, and it's saved here. And then this is synchronizing the data to over here. Now, if we wanted to migrate the data, what we would do is we would replay that same queue into another queue, have a different processor. Maybe it's Spark, maybe it's Akka, maybe we're migrating from Spark streaming to Kafka streaming. It lands the data here. And in that case, by the way, if you're not using Spark streaming, you don't even need two data centers. You're just going to be processing it here directly into this data center. But in here, you may be using a different version of the schema, or you may be doing some special operations that you weren't doing here. And you would just replay the queue and have it process it. And then this data is separate, completely separate. There's no overlap. This is a different key space, objects A versus objects B, right? We have a different place of putting this data here. The messages, if you want to land them, they could be the same. So that's one way that you can think about it, is you can process the queue, save it into Cassandra, and then replay from Cassandra. And that's also a way of thinking about the queue, is that you don't have to always read from Kafka. And what I mean by read it from Cassandra, read the event log from Cassandra, but don't delete it. There's a different topic we can talk about, like why you shouldn't make a queue on top of a Cassandra table, meaning have items that then get deleted. That's an anti-pattern. But it's okay to just append data and then read it, right? Replay the data, that's completely fine. And then there are some ways to actually have like your own offset, but at that point, you're basically creating your own Kafka on top of Cassandra. Somebody's already done that, by the way. It's not called Kafka on Cassandra, but it's very similar. So yeah, you're basically writing events to a queue, and you write data from the queue to, let's say, A. After you migrate, you write data from the queue to A and B. You read the data from A, you validate the parity, and then you start to do both operations from B. And at the high level, it's not that different. But when you get to the actual implementation, events sourced via persistent queue is different from if your software just does dual writes and dual reads. Okay, they're architecturally different, but strategically they're the same thing. And these are online migrations. So why would somebody need an online data migration? Well, the system cannot go down. If it's a managed software, like if it's a software as a service or it's a platform as a service, the end users cannot take any downtime. End of story. Because the platform provider or the software provider is promising uptime. Any migrations to any customer cannot be affected in a maintenance window. So this would be one way to do that, meaning completely online. What are the tools to do this? That's a subject for a different discussion. As I was just alluding to, there's various ways to do that queue processing, and then there's various different software approaches to do dual writes and dual reads. Offline migrations are a lot simpler. I don't want to say they're brute force, but they're kind of like the true and tried method of moving data. You take the schema, you take the data, you move the data, you run it. End of story, right? So here's some of the ways that I have. Sorry about my typos. That I have used with Cassandra and DataStax. And this is pretty much the same. It hasn't changed much. I'm trying to think if there's any new tools out there. I'll think about it. I mean, there are some commercial tools out there that are useful. There's another way to do using some CDC, but I would really put that up here because it would use Kafka in the middle. So CQL Copy, it's part of CQL SH, right? You can say CQL SH, either go into the shell or pass it the command to copy a table into a CSV file. You can even specify which fields or to rename the columns. You can do basic stuff like that. I don't think you can do advanced. You can do basic things like change the delimiter, etc. Same thing, you can do an import. You can import from CSV into Cassandra. This works fine, but it works for data under a gigabyte or so. And anytime you're doing this, I would highly recommend not using it in production unless you know for sure your data is never going to be bigger than 1 GB. But at that point, I'm going to ask you, like, why do you have data that's under a GB in Cassandra in the first place? But maybe it's 1 gigabyte for for a customer, and that's it. But even then, if you think about CQL Copy, it's using the same rules as core CQL. If you're using DataStax search, you may be able to do this effectively across multiple partitions, but again, this is doing a table scan and it's doing an export. Now, there's a newer tool that DataStax has released that's similar to CQL Copy. It's called DSBulk. DSBulk works. It's got these complex, I call them complex because I'm lazy, but it's a way to really encapsulate what you want to do from X source, like cluster, to Y source file, or from X file to Y cluster. I have not tried this, but I've theorized that it's possible to take DSBulk, pipe to standard output, and then have another DSBulk take from standard output and put it into a cluster. I don't know if that'll work, but it's Unix, right? Anything is possible. But this is as a solid tool. It can do a lot. It takes time though, right? It's multi-threaded. You can tune how many executors. It's not like Spark, but you can tune this in terms of execution, how many resources it needs and whatnot. But it works pretty well. I would say people use this in production. It works great. It works with Cassandra. It works with DataStax. It works with any Cassandra compliant system. So it's worth taking a look into. Now, the world of Spark is where people get a little afraid of it if they've never used it. But using Spark, you don't need DataStax to use Spark with Cassandra. It just makes it easier. But you could create a Spark, one node Spark cluster, right? You can go to your infrastructure provider and say, I need a big machine with, I don't know, 64 gigs of RAM. And you can have literally one Spark master, one Spark worker, and use it to move data more effectively than CQL Copy or DSBulk. Why? Because Spark will take whatever job you give it and spread it amongst the CPUs better. And if you have more CPUs, right, more cores in different machines, it does that. So again, using Spark with Cassandra is a deep topic. Using Spark with Cassandra for like admin data operations, like what we're talking about here, it's commonly misunderstood by DBAs. They think, well, that's a technology that has nothing to do with Cassandra, so I don't need to learn it. But if you're a Cassandra DBA, if you're a Cassandra data ops person, you kind of have to know it, because you're missing out on one of the best made matches in technical universe of Spark and Cassandra. You may not be building distributed applications with it, but you can at least use the power to get data in and out, right? So we'll take a look at a quick snippet of a Spark script, as well as a Spark job, like a compiled job. We'll compare the pros and cons. And then the Spark Migrator, it's actually Scala, the C++ variant of Cassandra. They put out a Scala Migrator. I just call it Spark Migrator, because I don't want to give them. I like them, but I really think it's just a Spark Migrator. But it can take data from Cassandra and move it to Scala. That's why they made it. But it uses the Spark Cassandra connector for both. So you can move data from one cluster to another cluster, from one key space to another key space, one table to another table, all in the same tool. And you don't need any, in this case, I should say, this is not a purely offline method. You kind of need both clusters. We'll take a look at that in a second as well. SS table loader. Well, let me quickly review the pros and cons. So I would say that Spark works well all around. It works for all data sizes. A Spark script, meaning like one that you copy and paste into the Spark shell, you want to store those in some sort of, GitHub or Bitbucket, because if you're working with a team of people and you want to empower them to do some stuff, you want to make sure that this is managed in a source control. The Spark job definitely needs, source control. You don't want to be just floating stuff around. Spark Migrator, it's a compiled jar. You don't need to compile it or do anything with it. All you need to do is to manage the parameter files. We'll take a look at what the parameter file looks like. Another thing to note, Spark will put stress on the cluster or data center that you're operating on, not just the Spark node itself, but the Cassandra side of it. It has to do these operations. So when you're using Spark, would recommend having a different data center where you're doing this, export from and import into, so that you're not impacting the transactional data center. But if you can't help it, you can always tune Spark to do less work with less resources. And then event sourcing, event processing, we talked about it. There's a billion different ways to do it. Different software can do it. It's just a matter of what your environment is consisting of. CQL Copy, built into Cassandra. You got it, right? Major cons, not for large data sets. The timestamps are not necessarily preserved. You can, I think there's a way to say use this column as a timestamp, but I have to double check. SS table, moving SS tables, usually it's used for backup and restore, but you can use raw SS tables to move data. So there's SS table loader, and there's something called a mirror loader. This is something that comes from the Scala DB world, but it's really, I'll bring up the article in a second if I find it, but it's just a part of Scala toolkit, but you can use the same idea. But basically you make a snapshot to a temporary data center, and you sync the new data center with the original data center, and and you still have some active. You have like it's a topology thing, really. So Spark scripts. So Spark SQL, you know, you can do something like this in Spark SQL. You could say insert into this table, right? Select from, and you can do that select from this other table. Right? And you don't think this is possible in relational. I'm sorry, it is possible in relational. You'd say it's not really possible in Cassandra, but it's possible with Spark. Right? So if you're used to being able to do this in the relational world, why wouldn't you want to necessarily use this? Very powerful. You can also use Spark Scala shell. This is a shell, and it's a Scala Spark REPL, meaning, so just like Spark SQL shell, and you could even do this inside Scala itself, but what happens is you can run Spark shell, copy and paste something like this, and what it's going to do is it's going to read from this table dummy in the KPI key space, and it's basically writing it to this other table. And what they did here was they changed a little bit. They changed some basic aspect of their key. They set this as a different key. It's a different value based on the first key. They had a different key here. So you can do some manipulation of the data as well. And, you know, 5 lines of code, move data from one table to another, one key space to another. And if you want, you can do from one cluster to another as well. You just have to connect to both clusters. Okay. So in this case, it's, you know, how do you move from one cluster to another? So this is cluster 1. This is RDD from cluster 1. And then this is cluster 2. And we basically save it back. The difference here is that we're using data frames in the same cluster. In this case, we're using RDD to populate something and then to use it to set it back. We can technically use RDDs as well. Sorry, data frames, but you have to copy the data frame. And then a Spark job. So what is a Spark job? Spark job is just taking something like this and compiling it. And it's a jar. And if you parameterize it, you can reuse it in different ways, or basically it's a, you know, stupid proof, right? If you compile the logic, and if something needs to be moved, you script around it, somebody can't make a drastic mistake in the Spark. Right? That's really what the Spark job is going to be doing. And you don't have to do a Spark job in Scala. You could do it in Python. You could do it in R. You could do it in Java. You can even do it nowadays in C# and in Kotlin, if you're up for that. So Migrator, Spark Migrator, one of my favorite tools. If you look for Migrator, don't tell me you guys broke the search. There we go. Yeah, so this is it, Skill Migrator. And it's a jar. And you say, you know, here's my config file. And what it will do in the config file, it will read from and write to. So what does the config file look like? Config file is, here's a sample. For source, type Cassandra, here's the host. Credentials, which key space, which table. Do I want to preserve timestamps? Split count, this is the it's the Spark Cassandra connector parameter. How many connections to use and how many rows to fetch. This is also, these are actually all core Spark Cassandra connector parameters. And the reason they give this to you is that maybe you don't want to overwhelm one meaning the source or the destination cluster. Now, this I did not realize, but it looks like they also have a Parquet reader. So they can read from Parquet and write to Cassandra. I did know that they have a DynamoDB loader to load from DynamoDB. And then, of course, their goal, Scylla's goal, was to make you use Scylla as the target. But as long as this is a change to Cassandra, you could send it to Cassandra or DataStax. And apparently, they also have a DynamoDB target. I don't know if they have a Parquet target. Might be useful. Save points. This is useful if you have a lot of data. You know, if your thing breaks for some reason, your cluster breaks, and you want to redo it, you don't want to have to remove all the data. This is also useful. You can rename your from to a destination column between this source and destination. Useful if you want to do a data migrator between two different schema changes and a column name change. And then this is a validator. It goes and actually compares a source target from Cassandra to Cassandra. The reason they say Cassandra to Scylla is that it's going to do a Spark job. It's literally going to do a select after it does the movement to say, you know, how are we doing? Okay. Powerful tool, highly recommend it. Learn it. If you're doing Cassandra, learn Spark. You know, you don't need a whole cluster to do it. As I said, you can do it on a one node cluster. And actually, both you know, Amazon and all three, Amazon, Google, and Microsoft has their own version of Spark, hosted Spark. So that's one way to get into it. The other is you can do Docker. So this has a Dockerized version, which, where is the Docker file? Right, so it's using, in this case, it's using Cassandra and Scylla, and then it's using this Spark Docker image and this worker Docker image. And you can even have multiple workers if you want, but you can run it on Docker. Then you don't even need to know how to install Spark. This is doing everything for you. And back to this. So that's really, you know, probably the best tool I know for moving data live and offline. I'm not going to go through this aspect of it, but basically what DS Bulk can do with awk is that once you get the data into CSV, you can use sed and awk to manipulate the data and then use DS Bulk to then bring it back in. But it's the same thing that you would do with like CQL Copy and awk. You know, that's just basically being a ninja at Unix. Using sed and awk to do all your data manipulation is kind of baller. So, you know, I think this will become a blog post now that we've had a talk about it. But we are at the top of the hour. Wanted to thank Dipan for the question related to SS Table Loader. Really good question. I think we want to cover that, come back and see, you know, what's happening. Don't forget to subscribe to Cassandra Lunch on YouTube or our YouTube channel, and put your email address into Cassandra.link for the upcoming newsletter. Thanks, everybody. Good to see all of you. At least your names on a black window next time. Maybe show your face. Peace out.